Hey, everybody, how you doing? Lesson 5, negative exponents. I know how much you love the laws of exponents, so you're going to just adore this, all right? We have negative exponents, and guess what? All our laws still work with negative exponents, okay? But we have to figure out what a negative exponent is, and this is going to build up so that we can use the negative exponents when we talk about scientific notation. Special way to write really small numbers and really large numbers. All right, so what is a negative exponent? We're going to go look over here in this little chart here, this little table, and we're going to try to see a pattern. All right, so we have exponential form, we have standard form. We also are going to have expanded form over here. All right, I'm going to start by let's just make sure that we always have a 1 here in our expanded form, 1. And then we are going to say, okay, well, 10 to the third means times 10 times 10 times 10. All right, 10 times 10 is 100. 10 times 100 is 1,000. All right, so let's look at that next one. It looks like we have an order. It gives us 100 over here. So we're going to give the power. So 100 is 10 times 10, so that's 10 squared. If if we write the expanded form, we would get, right, 1 times 10 times 10. Looking for patterns so we can understand this better. All right, 10 to the first power. Well, that would be, we start with a 1 times 10. All right, so that's just 10. Look at this next one. All right, we still have the 1. But how many 10s are we going to multiply by? Right, we're looking at that. 10 to the 0, well, we're going to multiply the 1 by no 10s. So the answer to 10 to the 0 is going to be 1. All right, so anything to the 0 power is 1. Now, what's next? All right, so let's throw in with a different color. 0, 0, 0, 0. All right, so far that 1 keeps creeping closer to the decimal. All right, so now we're going to talk about, all right, what if it goes over that way? What if it goes to the right of the decimal? And what do you notice about all these powers? We're going down, down, down. Well, what's below 0? So we're going to take this pattern a little further. 10 to the negative 1. All right, 10 to the negative 1 means, how would I say this? 1/10. All right, so look at the top here. We go 1,000, 100, 10, 1, and now we're on the other side. 1/10. Now let's do 100th. 0.01. Well, what would the exponent be for the 10? If it keeps following the pattern, that's 10 to the negative 2. All right, so we're trying to figure out what negative exponents mean. Well, it looks like we've gone times 10 times 10 times 10 for 10 to the third, then times 10 twice, then times 10 once, then times 10 0 times. Well, now that we're getting below or in between 0 and 1 here, it actually, a negative exponent is just, dividing by 10. So 10 to the negative 1 is just dividing by 1 10, a single 10. And then we have 10 to the negative 2 would be divided by 2 tens. All right, so let's try this last one. What would be in this last column? 10 to the negative 3, we'd get 0.001, which is 1,000th. And, excuse me. So then we have the 1, and we're going to divide by 3 tens. So just like a positive exponent can be thought of as telling you how many times to multiply something, a negative exponent is almost like how many times you're going to divide by something. All right? We can also think of it, if we write these in kind of fraction form, all right, where this would be 1 over 10, this next one would be 1 over 10 to the second, and this last one would be 1 over 10 to the third. So when we write them all, it's 10 to the third, 10 to the second, 10 to the first, 10 to the 0, and then it's 1 over 10 to the first, 1 over 10 to the second. So what do we call it when we kind of flip over a fraction? We flip over a fraction. It is a reciprocal, so, or a multiplicative inverse. So the negative exponents, if you see the 10 to the negative 1, we can write that with a positive exponent by just making it into its reciprocal and turning the exponent positive. So we can write 10 to the negative 2 as 1 over 10 to the second, and 10 to the negative 3 as 1 over 10 to the third. All right, so what is a negative exponent actually? What is it? Well, it's either repeated division. We can think of it as repeated division, or we can relate it to reciprocal or multiplicative inverse. There we go. That's a terrible M. All right. So here you can pause and you can copy down that. And then I'll talk to you about the numbers in the algebra. And then I'll zip through the examples. Let's go with the numbers. So if you have 5 to the 0, anything to the 0 power is going to be, according to up here, any non-zero number to the 0 power is 1. Remember the pattern up here, right here, right? When we are multiplying that 1 by no tens, it's going to equal 1. And then let's look at an example of a negative power. So if we have 7 to the negative 3, we can rewrite that as 1 over 7 to the positive 3. Pretty simple, right? Hopefully it doesn't scare you too badly. If we write it in algebra, we're going to use some variables. Any number to the 0 power is going to equal 1. But there is one little caveat, one little thing we have to be aware of. X can equal 0. All right, it can't be 0. This rule is only true if x isn't 0. Okay, and then we have x to the negative n is just going to be 1 over x to the positive n. So we just take the reciprocal and then we turn the negative exponent into a positive exponent. So let's try these ones out. I'll do the two examples. So we take the reciprocal. So 6 is reciprocal is 1/6, or multiplicative inverse. And then we just make the exponent positive. I'm sure you're getting the hang of this. So we take the reciprocal of the base and we take the opposite of the exponent. Reciprocal of the base, opposite of the exponent. All right, pause, try these 4, and then come back and see if you got them right. Hopefully you tried them. We're going to do the reciprocal of the base, and we're going to do the opposite of the exponent. B, reciprocal of the base, opposite of the exponent. 5 to the 0, anything to the 0 is 1. And D, we have m to the negative 3, so reciprocal. And then change the negative exponent to a positive. All right, I think you might be feeling pretty good about this. I hope you are. All right, example number 3, I'll show this one. Okay, it says write each fraction as an expression using negative exponents. So we're just going in reverse. All right, so we saw how we ended with 1 over 7 squared. Now we're going the other way. All right, we're going the other way. So how can I write this with a negative exponent? Well, we take the reciprocal. So it's going to be just regular 5, and then you change the exponent to its opposite. Okay, so that means 5 to the negative 2, you can think of it as a 1, and then divide by 5, divide by 5. Right? Dividing by 5 twice is like having it in a fraction, 1 over 5 squared. All right, now this one you might want to star. We have to actually, there's no exponent, and this says you can't just use negative 1. So you can't just say, oh, well, 36, and since there's no exponent, we put a 1 and then negative 1. Okay, you can't do that because it says you can. But what you can do is you can rewrite this as 1 over. Can anybody think of a way to do 36 to rewrite it with an exponent? Something that equals 36 but has an exponent. If you realize that 6 times 6 is 36, then you're on the right track. We can rewrite that as 6 squared. So we're going to rewrite something that's not a power as something that is a power. And then after that, we can, I'm going to write this down here. We can take its reciprocal and change the exponent to its opposite. So 6 to the negative 2 is the answer. Now we have to follow those same rules down here. Pause, see if you can do it. All right, we're back. So we take the reciprocal, so it's just going to be 8, and we change the exponent of 3 to its opposite. Now this one has the 4 in the denominator, has a 1 for the exponent. So we are going to have to rewrite it. And I know that 4 could also be written as 2 squared. So then I take that's reciprocal, and I take the exponent's opposite. This one should have been a slam dunk. I take the reciprocal and turn the exponent to its opposite. This one was probably the most difficult. You might be thinking, 27, how do I change that into a power? How do I rewrite an equivalent expression for 27 so that it's a power? Well, hopefully you realize that 3 times 3 is 9, times 3 is 27. So 3 to the third is equivalent to 27. And then we can go ahead and rewrite that as its reciprocal and turn the exponent to its opposite. All right, so definitely there's one for you to study because it's a little bit tricky. Ooh, this looks fun. All right, so we have to, this is kind of starting to introduce where we're headed. But this number 5 says 1 human hair is about 1/1000th of an inch in diameter. Write the decimal as a power of 10. So first, we're going to change the decimal to a fraction. All right? So we're going to rewrite decimal as a fraction. And we use the place value to do that. So that's 1,000th. Now, we're going to see what power of 10 that is. So that's going to be 1 over... How many tens does it take to multiply to get to 1,000? That'd be 10 to the third. And then finally, we can write it as a power of 10. So not a power of 1/10, but a power of 10. So we want to go with 10 to the negative 3. All right, pause and try I. And then unpause and check it out. All right, I'll show you a little trick here. 10, that's 1/10, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's 1 over 10 to the 10th. Excuse me. Which is going to be written as 10 to the negative 10. All right, hopefully you got close to that one. And that is all for our negative exponents. Psych! We have to use the rules. All right, so which of the 4 rules can we apply on this first one? That is the product of powers property. Look it up in your notes for the quiz the other day, and you'll see that we keep the base and we add the exponent. So that's 3 plus negative 5. So that gives me 5 to the... What's 3 plus negative 5? That's going to be negative 2. So that's 5 to the negative 2. Or I can rewrite it with just a positive exponent by writing it as 1 over 5 to the second, right? Take the reciprocal and take the opposite of the exponent. Ooh, so we have the division, quotient of powers property. Quotient of powers property says we keep the base and we subtract the exponents. Ooh, this is going to be tricky. Negative 1 minus negative 4. Yes, you need the minus. And then that becomes plus. I have a dance move for this. So you get negative 1 plus 4, which becomes 3. So that's w to the third. You got 4 got it's, and then we'll wrap it up. 4 got it's. Try your best, pause, and then check it out. All right, we're back. We keep the base. This is the product of powers property. We got negative 8 plus 2. So that would be 3 to the negative 6. Or we can rewrite it with a positive exponent and take the reciprocal and take the opposite of the exponent. All right, k. We're going to divide. So we're going to do the top minus the bottom. It's always the exponent from the numerator. Numerator goes first. And the denominator goes second. All right, so then 11 to the 2 minus 4 is going to be negative 2, or we can write it as 1 over 11 to the second. This is again the product of, the product of powers property. And that's going to be n to the 9 plus negative 4. So that gives us n to the 5th. Quotient of powers again. And so we have keep the base, take the numerator's exponent minus the denominator's exponent. That gives us minus a negative, which becomes plus. And we get b to the 3rd power. Woo! Thanks for hanging in there. Good work. All right. Hopefully, with some practice, you guys will be experts at this as well.